some basic operations in signal processing. What are the basic operations we can do? We can do two types of basic operations. Two types we can do operations on amplitude values of the signal. We can do operations on independent variable. That means we can do operations on x-axis, and also we can do some manipulations in y-axis. So based upon on which variable we are going to perform operation, these basic operations are divided into two types. First type of basic operations performed on dependent variable, and second type of operations are performed on independent variable. So I am saying sometimes y-axis, x-axis. Why? Because to get understand, you have to understand. If I am saying dependent variable, independent variable, you won't get understand. So you have to assume what ma'am is saying. So for that only I am using x-axis and y-axis. Are you getting my point, ma? Here what is
Yes, ma'am.
x-axis? For DT signals, what is x-axis? For DT signals, independent variable, what is the independent variable? Represented using n. And y-axis corresponding amplitude x of n. X of n means dependent variable. Function is said to be dependent variable. No. Function value varies with an independent variable. Okay. So now we will see these operations. And before going to see why we need these operations, I want to explain first, ma. Then only we will move mathematically, graphically, how we will see. First, I will explain why these operations are required in real life, where we are using these operations. So, we need to increase intensity of the image. Let us consider image processing application. In that, we need to increase brightness of the image. So, to increase the brightness of the image, we are going to intensity level. We are going to increase the intensity level of the image. Isn't it, ma? Can anyone?
Yes, ma'am.
So, in that process, we will use this either integration or addition. Addition of two, multiplication. We will use multiplication. By multiply that intensity value. Here, intensity image processing. What is the dependent variable, ma? What is the amplitude? It is representing intensity only, no? In image processing. For an image, what is the y-axis value? It is intensity. So, there we will use this multiplication. If we multiply amplitude value, if we increase, then only we will get a brighten image, isn't it? So, like that, we will use these operations on dependent variable. What is dependent variable here in image processing? It is maybe intensity, like that. In speech signal processing, what is dependent variable? Acoustic pressure. We increase volume, we decrease volume. That means we are doing some operations on dependent variable. So next, we are going to do basic operations on the independent variables. These are also called transformations. These basic operations performed on independent variable also called, we can say like this also, transformations on independent variables. Those are time shift, time reversal, and time scaling. So, where we will use these operations. Why we have to shift in time, why we have to reversal, why we have to scaling, where we will use these operations in terms of applications. So, for example, you assume radar signal processing. What is the application of basic primary application of radar, ma? If you know, anyone, what it will do, ma? Radar. It will detect. It will detect the target. If you don't know, I am saying radar is for detection of targets. Whether that plane is present here or not. Like that, for detection of planes, we will use radar. So, there we will send a signal, and at time t is equal to 0, we are sending. You assume like now we are sending the signal. It has to travel and hit by the target, and it has to return back to the radar. So meanwhile it is taking some time, isn't it, ma? Meanwhile it is taking some time. Are you getting my point? We are sending the signal
Yes,
at
ma'am.
time t is equal to 0, and you can take fraction of seconds, it will return back. So we can call it as there exists some shift in time. At time t is equal to 0, we cannot get return signal. We will get only the return signal after some time. It may be fraction of milliseconds also, but we cannot get the same signal back at time t is equal to 0. Okay. So example for time shift is like this. And next one, time reversal. Where we see time reversal. If we are watching some video of CCTV cam, so if you want to see particular image, if it is fast forward, we will have to come back, no, to see that one. We have to reverse it, isn't it, ma? We have to reverse the video. We have started from t is equal to 0, and we are moving, and at particular point we have seen that it is gone. So for that, to see it again, we have to come back, no, reverse. My dear students, are you getting my point? Reverse.
Yes, ma'am.
In earlier days also, by using DVD or CD players, we will reverse. We will reverse the application. That means we will reverse the audio. We will reverse the video. So there, we will use this time reversal operation. And also last one, time scaling. Time scaling where we will use means, for example, let us consider in image processing. In image processing, we are having some small size of image. So to see that image, we want enlarge of that image. We have to expand that image and we will see. In real life, what we will do like this only. We will have small image, we want a big image of the same. We will use this time scaling. That means these operations are performed on independent variable. What is independent variable here? N, isn't it, ma? What is independent variable? We are talking about independent variable. What it is here? N. For image, it may be different. For speech, it may be different. For video, it may be different. But here, throughout our subject, we will see one-dimensional signals which are consisting independent variable as discrete time, that is represented by n, and dependent function, dependent variable signal as x of n. So with this introduction of basic operations, I will move on to first basic operations on, these are the transformations on independent variable. First we will see for independent variable, then we will see dependent variable. And independent variable, you know that it may be continuous, it may be discrete, isn't it, ma? Independent variable, it may be continuous and it may be discrete. So first operation, theoretically I have explained, application wide I have explained what is time shift. That means at time t is equal to 0, for example, you see here, at time t is equal to 0, the signal is having maximum amplitude. If we shift either right side or left side of y-axis, we will get this one. At time t is equal to 0, we are having maximum amplitude. Now we are delaying by t naught. At time t naught, now we are having maximum amplitude. It is delayed signal, called as delayed signal. Instead of having time t is equal to 0, we are having maximum value at time t is equal to t naught. So it is called as delayed signal. And if we put time t plus t naught, if we shift this independent variable as t plus t naught, we are adding some t naught constant time term, some constant time t naught to our independent variable t, then you will get like this. If we add time, you will get shifted version, left hand side shifted version, and also that is called advanced, time advanced. This is called, before t is equal to 0 we are getting, ma, before t is equal to 0 we are getting this one, so we can call it is advanced, no, isn't it, ma? Students, it is existing at time t is equal to 0, ma. So if we are getting before t is equal to 0 the signal we are getting, so we can call it as it is advanced. And after time t naught we are getting signal, so we can call it as delayed signal. We can call it as delayed signal. You see here, this is equation for shift in time. Actually, we will use for discrete time. Throughout the subject, we are going to solve for discrete time signals. So move on to next slide. It is showing shift in time for discrete signals. Let us consider this signal which is shown here, x of n. Now, if this x of n is delayed for some positive n naught, how much delay here given, ma? By seeing this graph, you can say how much delay here. What is the value of delay? It is 2.
X of n minus 2.
What is the delay? N minus 2. We are doing n minus 2. So n minus 2 means what is n naught value? N naught is
2.
2. N naught is 2. So this is, you can say here, it is started from minus 2. And this graph is started from n is equal to 0. So we can say it as delayed. Late, no. So delayed. We are getting at minus 5. If we do x of n plus 3, if we add plus 3 to the independent variable, the same graph will be plotted as like this. So we will get from minus 5, it will be shift towards positive values of n or towards negative values of n. So n plus 3, already we are having from minus 2, minus 1, 0, 1, 2, we are having the original signal. If we shift it by plus 3, that means You have to substitute here n is equal to 0, n is equal to 1, n is equal to 2, n is equal to 3. Like that, n is equal to minus 1, n is equal to minus 2, n is equal to minus 3, n is equal to minus 4, and n is equal to minus 5. In the second graph, this one, are you visible my cursor, ma?
Yes, ma'am.
Here, you put n is equal to minus 5. What will happen, ma, this one? N is equal to minus 5. X
Minus 2.
of minus 2. What will happen? If we substitute n is equal to, now we are plotting a new graph. It is a new graph. If we substitute here n is equal to minus 5, what we will get? X of minus 2. So what is x of minus 2 value from the original signal? It is 2, isn't it? So we will draw the sample here. Next, substitute n is equal to minus 4 here. X of minus
Minus
4,
1.
X of minus 4 plus 3. What will happen here? X of minus 1. So what is the shifted value now? At n is equal to minus 4, we are calculating. At n is equal to minus 4. So go and substitute here minus 4 value. It is nothing but x of minus 1. From the original signal, see x of minus 1 value. What is the x of minus 1 value? It is minus 1. So here at n is equal to minus 4, for shifted version we are plotting now. It is minus 1. And substitute minus 3 here.
0.
X
X
of
of 0.
minus 3 plus 3. X of 0. So what is the x of 0 now? It is
0.
3. Here,
Okay.
x of 0. What is it? Value amplitude?
3.
3. At n is equal to 0, it is 3. So here we are calculated for what n value? For minus 3 only, no? We have calculated. Minus 3. If we substitute this minus 3 here in the place of n, x of minus 3 plus 3, x of 0. What is the x of 0? Will come here. Are you getting my point, ma? We are
Yes,
calculating
ma'am.
n is equal to minus 3. We are calculating amplitude value for n is equal to minus 3 we are calculating. So substitute this minus 3 here. X of minus 3 plus 3. So x of it will become 0. What is the x of 0 from original signal? X of 0 is, amplitude value is 3. That sample will come here. And similarly, we can have like this. So before time t is equal to 0, we are getting this signal. Before this sequence, it is starting. So we can call it as advanced signal. And it is starting lately. So we can call it as delayed signal. So coming to this graph, I will explain. It is x of n of minus 2. So here you substitute n value from, here we have started from minus 5. No, here also you start from minus 5. Minus 5 minus 2. What will happen, ma? Minus 5 and
Minus
minus 2.
7.
Minus 7. X of minus 7 value is there here? For minus
No,
7
ma'am.
is the values exist? No. So minus 5 we should not take. Minus 4, take minus 4. Minus 4 minus 2. What will
Minus
happen? Minus 6. Yeah, for minus 6, x of n exist? No.
No, ma'am.
So go like that. Minus 3, minus 2, minus 1. No, we are not having. For 0, for n is equal to 0, put here n is equal to 0.
Minus 2.
I want more replies, students. Put n is equal to 0 here.
Minus 2, ma'am.
x of minus 2. We are having for minus 2, no?
Yes,
And we
ma'am.
are calculated for n is equal to 0. So the same sample value comes here now. And next one, for n is equal to 1, we are calculating. Put here n is equal to 1. X of
Minus 1.
minus 1. We are having x of minus 1. And which is nothing but minus 1. That amplitude is nothing but minus 1. So minus 1. At 1, n is equal to 1. What is the value now? And next one, for n is equal to 2, we are calculating now. For n is equal to 2. So put n is equal to 2. 2 minus 2 is what?
0.
0. So x of 0. What is the x of 0? You see the original signal. To get the amplitude value, it is 3. And we have calculated for 2 only. Isn't it, ma?
Yes, ma'am.
You have to calculate next for 3. To calculate the shifted signal x of n minus 2 for 3. Substitute this 3 value here. You will get 3 minus 2 as 1. And what is x of n 1 value? X of 1 from the original signal.
2.
It is 2 amplitude. So 2 amplitude we will get here. So you have to substitute these new n values in the here and you will get an result as 0, 1, 2, 3 and x of 0 from original signal. If it is exist means it will comes at new place, shifted place. Shifted place. It is shifted to 2, no. N minus n naught, ma. It is shifted by 2 units. It may be right shift. It may be left shift. If it is x of n minus n naught, if this n naught is positive, it is shifted to right. The same shape, are you seeing that? Same shape? Our shape is varied. Students?
Varied, ma'am.
Shape is same. Shape same. It will increase, it will decrease, it will increase, it will decrease. Shape is same. Pattern is same only. Pattern. But it will shift from left, it will shift to right. If it is n minus, if it will shift to right side by this unit. 2 is there, no? This origin is shifted to now 2. If it is plus 3 here, n plus 3, then the origin, you see here, n is equal to 0 sample. Where it is now? At minus 3. You will have, if we shift n minus of minus 3, you can write n plus 3 as n minus of minus 3. So, n minus 3. So, where it will shift now? To minus 3. N minus 2. It will shift to 2. Are you getting, ma? That's why I have taken like this. X of n minus n naught. I didn't put here n plus n naught. I didn't put here x of n plus n naught. Usually, the shift is like this only. X of n minus n naught. The n naught may be positive. The n naught may be negative. Minus of minus, it will become plus here. So, n minus 3. This one is n minus of minus 3. It will shift to minus 3. You remember n minus. Shift means what, ma? N minus. If it is 2, it will shift to 2. If it is minus 3, it will be shifted to minus 3. Are you getting my point? If I put
Yes,
here
ma'am.
instead of 2, in second graph, if I put 4, what will happen now? If I put instead of 2, 4. If I put 4 instead of 2, this x of n minus 4. So this initial n is equal to 0 sample will move to 4. Isn't it, Mari? Getting my point?
Yes, ma'am.
It will be shifted. If it will be shifted. If it is positive, it will be delayed. If it is negative, n naught value is negative, it will be